Welcome. Today we're going to look at vacuum filtration, which is an easy way to separate solids from liquids when doing chemistry. Unlike gravity filtration, vacuum filtration takes advantage of a vacuum to draw the liquid through a funnel. In our labs, our source of vacuum is a water aspirator attached to a faucet in the lab benches. When you turn the faucet on, water rushes through the pipes and is constricted in the neck of the aspirator. Thanks to some interesting physics called the Venturi effect, as liquid flow increases through the constriction, it reduces the pressure inside that constricted tube. By carefully placing an opening perpendicular to that constricted tube, we get a vacuum. If you place your finger at the end of this inlet, you can usually feel the vacuum. You'll want to attach a thick-walled rubber tube to this vacuum inlet. You'll then attach the end of that hose to the glass barb on the vacuum flask. The vacuum flask is a special type of conical flask with thick walls that allow the flask to withstand the vacuum. Just as a note, before using any glassware under vacuum, you should always check the glass for cracks. If you find a crack, ask your instructor for a replacement vacuum flask. Also, put on your lab goggles before working with any glassware under vacuum. Once you attach your rubber hose to the vacuum flask, it is not uncommon for the rubber hose to apply a force to the flask, which might make it fall over. A quick fix for this is to simply attach the vacuum flask to a clamp. I recommend doing this for any vacuum filtration with a relatively small vacuum flask. Next, you'll need a Buechner funnel. These come in a variety of sizes and types, but the ones we use in the lab most often are these plastic ones. The Buechner funnel has holes in it that allow liquid and air to flow through it easily. However, these holes are big enough to allow your solid compound to flow through as well. So, we'll need to use a perfectly sized filter paper to cover these holes. Once you've got your filter paper in the Buechner funnel, you'll need to turn the vacuum on and make sure the filter paper is covering the holes and is held securely in place by the suction. I recommend using a bit of solvent to wet your filter paper and then applying the vacuum to hold the filter paper in place. In this case, the solvent is water, but you might have a different solvent, so check your procedure. At this point, I think it's worthwhile to make sure that your vacuum flask is clean. If something goes wrong during the filtration, you want to be able to recover the material in the vacuum flask without worrying about contamination. Once you are confident your filter paper is ready to go, carefully pour your mixture through the Buechner funnel. The liquid will be drawn through the filter paper and into the vacuum flask. We refer to the liquid that passes through the filter as the filtrate. The solid material in your mixture should remain on the filter paper. The solid on the filter paper is called the filter cake. It is not uncommon for some of your solid to remain in the flask that you poured from. How you deal with this depends on how soluble your compound is in the solvent. If it's not soluble, you can simply add a bit of that solvent into the flask and pour it through the Buechner funnel. The last topic I want to discuss is the use of a filter aid. Usually, we use a filter aid when the product we're interested in isolating is dissolved in the solvent and the solid is an impurity made up of very fine particles. In this particular mixture, we have an ionic product that is dissolved in an aqueous solution. But we also have a solid impurity called manganese 4 oxide that is made up of very fine particles. If we attempt to filter those particles out with just a piece of filter paper, the pores of the paper will get clogged up and no more liquid will flow through the filter paper. We call this blinding, which will bring your vacuum filtration to a screeching halt. This is where filter aid comes into play. The filter aid allows us to collect the fine particles of powder in the filter cake before the particles ever make it to the filter paper. The filter aid we're going to use in this filtration is sea light, otherwise known as diatomaceous earth. Oh, by the way, diatomaceous earth is very bad for your lungs, so avoid breathing in the dry powder. To prepare the filter aid, you need to create a slurry of your solvent and the diatomaceous earth. Next, set up your vacuum flask, Buchner funnel, and filter paper so that no solid can get through the Buchner funnel. Then, carefully pour your sea light slurry through the filter paper. You want to make sure that you get a nice, even filter cake made up entirely of your filter aid. Then, before you do your filtration, empty the vacuum flask of any solvent you collected. There shouldn't be any sea light in that liquid. Now, you're ready to do the filtration. Carefully pour your mixture through the Buchner funnel with filter aid in it. Pour slowly so that you don't damage the surface of your filter aid. Your filtrate should be clear and, in this case, colorless. You can wash the reaction mixture with more of your solvent, but you don't need to get all of the solid particles out of the flask. Your product should be dissolved in the filtrate. I hope you enjoyed learning about how to do a vacuum filtration and how to use a filter aid. If you have any questions or suggestions, please leave a comment below. Also, subscribe to the channel so that you don't miss our upcoming videos. Thank you for watching.